Hello students, Professor Piggy here. Today we are trotting confidently into the pasture of cloud computing, which refers to accessing computing resources from a location other than your local computer, most commonly through the internet. Instead of keeping every server, application, and storage device in your own sty, those resources live in a distant data center while you connect to them over a network. The wolf may snarl about distance and mystery, but the exam only cares that you understand remote access and provider management. When you use web-based email, such as Gmail, you are using cloud computing in a very specific and testable way. Web-based email is software as a service, commonly called SaaS, which means the provider delivers the entire application over the network. You access it through a web browser, and you do not manage the operating system, the hardware, or the application itself. You may know you are online, but you do not know or need to know where the physical server is located, no matter how loudly the wolf demands an address. Cloud storage is another widely used form of cloud computing for individuals and organizations. Services such as Apple iCloud, Microsoft OneDrive, and Google Drive store data remotely and make it accessible from many devices. Providers often offer a limited amount of storage for free and charge small fees for additional capacity. From an exam perspective, what matters is that storage is off-site, accessed over the network, and managed by the provider. Cloud computing is especially valuable for handling sudden increases in demand. Consider Black Friday in the United States when online retailers experience massive traffic spikes. Years ago, even Amazon struggled when its own servers could not keep up with demand. Rather than letting the wolf feast on failure, Amazon rented additional cloud resources for the holiday weekend, scaled smoothly, and avoided outages despite increased sales. That experience helped Amazon recognize that other organizations face similar challenges. This insight led to the creation of Amazon Elastic Compute Cloud, or Amazon EC2. Amazon EC2 combines virtualization with cloud computing to provide on-demand computing resources to customers. It is an important example of cloud infrastructure services and demonstrates how flexible capacity can defeat the wolf's brute force approach. Cloud services are commonly classified by delivery model, which describes what type of resources are provided to the customer. The three primary cloud delivery models are software as a service, platform as a service, and infrastructure as a service. These models are closely tied to the shared responsibility model, where the provider and the customer split duties. SaaS places the least responsibility on the customer, while IaaS places the most. Software as a service includes applications delivered over a network such as the internet. Users access SaaS through a web browser, and it usually does not matter which operating system or browser they use. The provider manages the application, the operating system, the hardware, and updates. The customer is responsible only for using the software and managing their own data. Web-based email services like Gmail and Yahoo Mail are classic examples of SaaS. The provider supplies all components of the email system, including storage and availability. Google Workspace is another SaaS offering that provides browser-based access to documents, spreadsheets, presentations, and other tools. Even when collaborators use different operating systems in different locations, SaaS allows smooth cooperation, leaving the wolf scratching his head. Platform as a service, or PaaS, provides customers with a pre-configured computing platform. This includes an operating system and supporting software managed by the provider. Customers deploy and manage their own applications without worrying about physical hardware or most system maintenance. Many providers describe PaaS as a managed platform solution. A typical PaaS example involves hosting a website on a virtual server where the provider supplies the operating system, web server software, security tools, and patches. The customer manages the website content and application software, but does not manage the server hardware. Problems with the platform are often resolved by the provider before the customer even notices. This allows developers to focus on building services instead of repairing fences the wolf has chewed through. In many PaaS environments, users never directly interact with the operating system. Serverless computing is often considered a form of PaaS, or a closely related evolution. With services like AWS Lambda, customers provide code and execution rules, while the provider abstracts even more infrastructure, including servers, scaling, and availability. Servers still exist, but all server management is hidden from the customer. Infrastructure as a Service, or IaaS, allows organizations to rent computing hardware and related resources. The provider owns and maintains the physical equipment and data center. The customer installs and manages the operating system, applications, and updates. This model provides the greatest control and aligns with the shared responsibility model by placing more responsibility on the customer. IaaS is commonly described as a self-managed solution. It is useful for organizations that want to reduce their physical data center footprint while retaining control over systems. By outsourcing hardware, companies reduce space, power, and staffing needs. This flexibility keeps costs down and keeps the wolf away from expensive equipment. Cloud services can also be categorized by deployment model, which describes where the cloud resides and who can use it. The four major deployment models are public, private, community, and hybrid. These models focus on access and ownership rather than on the type of service delivered. Mixing delivery and deployment models is a common exam trick used by the wolf. Public cloud services are offered by third-party providers and are available to anyone willing to pay. Companies such as Amazon, Google, Microsoft, and Apple provide public cloud services to the general public. Resources are shared among many customers, but logically separated. Because they are open to all customers, they are called public clouds. Private clouds are designed for use by a single organization. They may be hosted internally or operated by a service provider, but access is restricted to one customer. Private clouds are often used when security, compliance, or control requirements are strict. The key feature is exclusive use, regardless of physical location. Community clouds are shared by multiple organizations with common goals or requirements. These organizations collectively use the cloud and limit access to community members. The environment is designed around shared security or compliance needs. This model is less common but clearly defined on the exam. Hybrid cloud environments combine two or more deployment models, such as private and public clouds. The environments remain distinct but are connected to allow data and applications to move between them. Hybrid focuses on combining deployment types, often keeping sensitive data in private clouds while using public clouds for scalability. This balance keeps resources protected while still flexible, frustrating the wolf's attempts to break in. Multi-cloud systems are a different concept from hybrid cloud. Multi-cloud uses services from two or more cloud providers, such as Amazon Web Services and Microsoft Azure. The goal is often to avoid vendor lock-in and improve resiliency. However, multi-cloud environments require consistent security policies across providers, increasing complexity and management effort. Some security professionals favor multi-cloud strategies because outages at one provider may not affect another. This improves redundancy but adds cost and operational complexity. IT teams must maintain expertise across multiple platforms, increasing the risk of configuration errors. With proper planning, though, multi-cloud can still outsmart the wolf. Cloud computing concepts appear across many exam objectives, and understanding responsibility boundaries is critical. Always consider who manages the hardware, who manages the operating system, and who manages the applications. When you can clearly explain delivery models, deployment models, and the shared responsibility model, you are well prepared for exam success. If this lesson helped you lock the gate and keep the wolf out, remember to like and subscribe, oink.